Okay, so here's B-12, and my new camera came in to make videos, so the quality should get a lot better soon. I just have to pick it up. So the directions. You're given that f is continuous on this closed interval, 4 to 15, and the table of values below. Okay, so that table of values. How many zeros are guaranteed by the intermediate value theorem on the open interval 4 to 15? Guys, an open interval, that's very much like it's like when we have like four, you see this a lot in the intermediate value theorem, like this. Um, so so C is between 4 and 15, but not including the endpoints. All right, so that's what these soft parentheses mean as opposed to those brackets. The brackets mean we're including the endpoints. So yeah, this is exactly what we've been working with the intermediate value theorem, just a different type of notation. So then we're going to state the subintervals that can be used to explain why the zeros exist. We're not going to explain why the zeros exist. We're just going to use subintervals, or we're just going to show the subintervals that can be used in an explanation. Okay, so I went ahead and drew a sketch already. I messed up here toward 15 a little bit because this one, -1, wasn't low enough. But this is one example of how you could connect these dots. Another example of how you could connect those dots is like this. So if we connect the dots in the simplest way, then we'll be able to see only the zeros that are guaranteed by the intermediate value theorem. Okay, so guaranteed means there could be at least that many zeros. So if I look here, I see 2 zeros. I see these 2 zeros. If I look at this alternate way of connecting the dots, there would be 1, 2, 3, 4, 5, 6, 7, 8 zeros. So we've got it. So the IVT guarantees at least 2 zeros, but there could be 8. There could be more. All right. So the answer to A is 2. Now I drew a graph to see that, but you also could have seen it from the table just by looking for output values. That 0 is an intermediate value 4. All right, so that's kind of what we're going to do for part B. So part B, state the subintervals that can be used to explain why the zeros exist. So let's look at the full interval. From 4 to 15, the outputs are -3 and -1. 0 is not between them. So you couldn't use the full interval 4 to 15 to explain why there's a 0. So we got to look for subintervals. So how about 4 to 7? All right, 4 to 7, let's look at the outputs. -3 to -5. Is 0 between -3 and -5? No. All right. Let's move on. How about 4 to 12? Could we use 4 to 12? -3 and 8 are the outputs. Is 0 an intermediate value for -3 and 8? Yes, it is. So you could use 4 to 12. Oh, how about, so 4 to 12 has a subinterval, another subinterval. So 4 to 12 is a subinterval, but then 7 to 12 is another subinterval of the full interval. But it's also a subinterval for 4 to 12. So could I use 7 to 12? All right, look at those outputs. Is 0 between them? Yes. So I could also use 7 to 12. Now, you don't want to use both. Okay, but all right, so what I want to say is that 4 to, no, let me not even. Sometimes the more I talk, I think it could be more confusing. So basically, for one of the zeros, you could use either 4 to 12 or 7 to 12. I'll use 7 to 12. Now for the other 0, we have to find another interval that is completely separate from 7 to 12. Like you can't use now 4 to 12 because 4 to 12 is not separate from 7 to 12. So we're looking for, so you find one interval for one value, for 1 0. And now you need to find a completely separate interval. I mean, they could share an endpoint, but other than that, a completely separate interval for the other 0. So, I already used 7 to 12. All right, now I want a separate interval, so I got to move on. How about 12 to 15? Yeah, zero's between 8 and -1. So I also can use 12 to 15. So these need to be separate intervals, except they could share an endpoint, but nothing else. Okay, now for part C. How many values of C for which f of C equals -4 does the IVT, intermediate value theorem, guarantee on this open interval 4 to 15? So that means not including 4 to 15. So I want the y value to be -4. All right, so I'll go down 1, 2, 3, 4. And here's y equals -4, and it looks like there's 2 again. 2 again. D. State subintervals that can be used to explain why the values exist. So to explain why 2 values exist, I need to find 2 separate subintervals. Okay, 2 separate subintervals. And I need 2 separate subintervals where -4 is an intermediate value for the outputs. All right, so let's look at this whole thing. -3 to all right, so could I use 4 to 15? -3 and -1, -4 is not between them. Okay. How about 4 to 7? Look at those outputs. Is -4 between them? Yes. So I could use 4 to 7. Now I need to move on to a completely separate interval. So I'll move out of 4 to 7 and into 4 or 7 to 12. Is -4 between -5 and 8? Yes, it is. So I could also use 7 to 12. 7 to 12 for the other 0. And then, I mean, if you moved on, 12 to 15, 8, -1, 4 is not between them. So yeah, guys, the graph is optional, okay? If you could figure out parts A and C just from looking at the table and looking for, looking for places, looking for intervals where the value is intermediate for the outputs, then that's great. That's actually, when we get closer to the AP test, that'd be preferable because it would save you time. But of course, always draw a picture if you feel the need to, or if you feel like it would help you be more accurate. All right, I'll talk to you later.